Okay, one of the questions we get with our grip ring design on our Integrator centralizer is that we're worried about calcium carbonate and drilling cuttings or any kind of debris that may be in the well interfering with the ability of our bowspring to close and then restore. So what we've done here, you just saw installed, is a rigid 1/4 inch ring to show like a maximum pack off that you could get with a non-compressible item, very extreme. And then the next step we're going to do here is we're going to grease this up, and we're going to put sharp sand, equivalent of lost circulation material, in here on top of the grip ring, set it up, test it, and run it. We get it greased up well here. The aggregate we're putting in here is common sharp sand, which is mostly silica rock, but they're pretty good sized particles in there, probably 2,000 or better, actually better micron, and some smaller aggregate as well to infill. And we will load this up as much as we possibly can. It's almost self-coating, look at that. Okay, so the team has finished setting up the test fixture here. If you'll recall, this was upside down as we filmed and loaded up. The end with the simulated debris and the real debris is the up dip end of this. And we've placed chalk marks on here so that you can see the action. Right now, it's resting on the tapered shoulder of the upper ring. And as we start to film and come down in, the bow will appear to shift, but it's really the casing moving down and this lower grip ring driving into the taper to push it into the restriction. For reference, this is a 9 7/8 through an 11 7/8 with 12 1/4 open hole bowspring scenario. All right. So we're going to film here and observe what happens at the top side. That'll be a separate cut in.
Ready?
Yep. All right, let it rock. Now we've reached the restriction, and you can see the casing is moving down. At this point, we've fully collapsed the bowspring. We took a little additional starting force relative to the spec sheet because of the debris that we put in there on the top side. We're talking about 100 pounds. And now we'll pull the fixture out. The first thing you'll see is that the inner casing will move up. So this number will move away from the line, and then when the grip ring engages the taper here again, we'll be pulling the whole bow out of the hole. Now, as you can see, we're loaded on this upper grip ring. It's a little bit farther into the profile. So we've moved basically that 1/4 inch spacer that we put in there.
We pushed the grip ring up.
Correct.
By 1/4 inch.
We pushed it up by 1/4 inch internal to that profile, reflected here, Because remember when we started the process, we marked it with the grip ring and the weight of the centralizer on it. Now we're pulling out and that should remain the same.
Lift them up.
Yeah.
Pull up.
Yeah.
Ready?
Okay.
Go ahead and pick up.
Yeah.
Put it right here.
Oh yeah, there you go.
Right over here. Yeah. Okay.
And you see in here, the shim is still in place. This grip ring got spaced up a little bit farther than from where it began, based on this rig and the collapsing of the bowspring. So, there you have it.
So you can see right